kids, it's Jurassic James. Interesting things looking at Basilosaurus. Now here's a new animal that I don't ever go over much in any of my lectures or talks. So there's two models, newer and older. There is one from PNSO. If you don't know, if I've mentioned before, the PNSO are the like really high end. Well, not there's probably higher end, but they're the highest end collectors that I get usually. And that they're from China. So if you order one, it takes a while to get here. In the meantime, but I have these guys here. So first and foremost, my introduction to Basilosaurus in the world of toy was the safari tube. So if you go to Hobby Lobby or Michael's, they have little tubes of prehistoric, fish or prehistoric reptiles and prehistoric mammals. It was in there. So overall, I want to point out with Basilosaurus, the name means king lizard because they were first discovered in 1834 in what is now Louisiana, and they are the official state fossil of Alabama and Mississippi. And looking at them again, this is 1834, which is before 1842, which when the term dinosaur was coined. So people were still finding these weird creatures, like what are these giant sea creatures and different bones. So the idea is that it was thought to be like a mosasaur or a marine reptile-like animal. It turns out it was actually a whale, and when Richard Owen got hold of the information, he actually petitioned to change the name from Basilosaurus to Zeuglodon, but unfortunately, the rules of nomenclature, essentially Basilosaurus is the first name used. It's in the papers, it's everywhere, and nothing else had it before, so it sticks, even though it's not as accurate to describe the animal, which brings the point, what is it? It's a whale. Congratulations. You're like, whale, it looks like a mosasaur. Yeah, that's why they were confused at first. If you only find this fragmented, you're like mosasaur. And in fact, in some ways, Basilosaurus, if you don't adhere to like family tree or time periods, Basilosaurus is the mammal answer to mosasaurs. They both have large heads full of teeth. They both have two set of pectoral flippers and small, well, this guy is pretty big, but this guy's pretty small pelvic flippers and of course the tail. Now the difference overall, if you want to look, other than being a reptile and a mammal and scales and skin and all that, is that fish and reptiles swim like this, back and forth, and mammals swim like this. Just a little thing to know that, okay? So the safari one, like I said, it hits all the main points. I mean, they're so small, it's not a lot of detail, so I mean, it's a great model for what it is. This next one is a Collect A. It's 2017. I remember ordering. It took like a while to get here. So this guy here is a better. It's bigger, obviously. Now the weird thing about Basilosaurus is that their skulls are like 5 feet long, but their whole body is like 60 to 70 feet. So they don't look like they're proportioned, right? They were initially found in the American southeast, the southern states, but then. Like in 1904 or 5, they found one in Egypt, and then Pakistan and Morocco later on, and Tunisia. So it's been found around that area. So if you look at the plates, the Pangea is broken up by the Eocene about 40 million years ago. But the idea is that they were so close together they were today, and there was a sea called the Tethys Sea near Egypt and what we now call Egypt and Pakistan. That whole area was the Tethys Sea. So that's where these whales are evolving and going to the ocean. You think, I want to know more about whales evolving and going to the oceans. Go to JurassicJames.com. I have lectures that I have an events calendar I'm doing next year and all that, right? And all the ideas of what I plan to do so far. And so I do lectures on those processes more. The point is, Basilosaurus is not the ancestor of modern whales. Now, in order to explain that better, let me explain whales, or cetaceans they're called. In general, when you think of a whale, there's like 2 or 3 images that come to mind usually. The one that I like to look up or think about are the baleen whales. So, for example, I have here a 2000 and no year Schley blue whale, a 2018 safari sea whale, spelled S-E-I, sea whale, but you're like blue whales, a little smaller. Let's see, this one is also not labeled. It's from Portugal. This is a gray whale. Of course, I have a humpback whale from 2013 in safari. I bought this in Boston, actually. So these are baleen whales, in that the baleen are these really big protein, like our fingernail or hair-like structures in the whale, or the teeth should be. So these whales eat plankton. They open their mouths, water pours into the mouth, the baleen closes, and then it pushes the water out. And it's kind of like a filter, or like your screening out material. So the water gets through, but the plankton gets stuck, and they eat that, basically, right? And that's a very successful design because they're the biggest animals on Earth today. And also we see placoderms, armored fish. There was at least one, that was a filter feeder, about to be. And there's also, remember the Anomalocaris, my bug video, little double mouth thing from the camera? There's a relative of that. That's a filter feeder. It's pretty big. So that seems to work. So these are the baleen whales. The toothed whales are two main groups. First, people think of sperm whales usually. And the idea of sperm whales are interestingly terrifying as the largest carnivorous life forms on Earth. I think, yeah, they're bigger than the large predator dinosaurs. And they're like some of the loudest. They use clicks with echolocation. So the idea, I mean, well, I'm getting too much detail. So the idea is, the video has to be like 10 minutes. So the idea is, we have here a sperm whale, a beluga whale, and actually people call them killer whales. They're not actually whales, they're closer to dolphins. But actually, they're called killer whales because they kill other whales very well. You see how I did that? So where does Basilosaurus fall into this? Well, the idea is that it doesn't. It's none of these groups. You're like, well, it has teeth. Should it be a toothed whale? Not quite. It's the Archaeocete. I had trouble saying it. Archaeocete, which means it's an ancient whale. So this guy did not evolve into these. It lived with other whales that became these guys. And then the question is, wait a minute, I know whales have a history with Megalodon. Did Basilosaurus fight Megalodon? They're both from the Cenozoic. The answer is no. The idea is that there's time periods, and then there's epochs, and then there's formations. So Basilosaurus is from the late Eocene. So think 40 million years ago, there's Basilosaurus. It's dying out around 33 million years ago. Megalodon is from the Miocene, which is like 23 million years ago to like 5 million years ago. So the idea is that Basilosaurus never saw Megalodon. Now, Megalodon lived with sperm whale ancestors, one named Leviathan. There was a PNSO model of. It's really kind of cool. But overall, they did not meet each other. And that's like, even though modern humans have lived, well, our modern is in our form, Homo sapiens sapien, have saw saber-toothed cats, I never seen one, right? But the idea is that I would have, so just like our species overlap, but you have not, because you're like the newest human so far. Most of you are children, I believe, based on the algorithm. So the idea here is that they're separated by time and space. So the idea is that the Mosasaurus had this like life, it lived and died, and then a few million years later these evolved, and then they lived and died, and then the Leviathan evolved, which fought Megalodons, supposedly. So there's different branches. Now, I mentioned earlier the echolocation. So if you look at a dolphin skull, like, you'd think it was like really, this big bulbous part here, or the big bulbous part of the sperm whale's head. Turns out their skulls usually dip in, and there's a melon there, and that's the piece for echolocation. Basilosaurus seems not to have had that melon, and there's nothing to suggest that it dove deep like some of the modern whales do, like the sperm whales eating giant squid, right? So it appears, based on this, the one in Egypt, they found a Durodon, which is a smaller whale, relative actually, but had a bite mark on it from a Basilosaurus. So that implies, eating other whales. The ones in the further like Pakistan area maybe ate shells. In fact, their teeth, the front teeth are pretty good. They're like whale teeth or sperm whale teeth. The back teeth are incorrect for the model because the back teeth look like these kind of fringe, like leaf pattern. And Owen thought they may have actually been, I wouldn't say kind of like herbivores, but not quite. We think they may have eaten shells because they have two kinds of teeth. They're mammals, right? But that brings an interesting point. Now, I went over whales in general, cetaceans. Now let's see some other marine mammals. The example I give you are the sea cows. So you say, wait a minute, is this the whale? No, they're not. They're actually closer to, they're in a bigger group called Afrotheres, which means African beast, ancestry. So elephants are some of the closest living relatives to manatees. So what you're seeing is that they're not related to each other. I mean, they're all mammals, but within mammals, there's different branches. So Basilosaurus is definitely a whale. The other marine mammal that you may have heard of for season times are seals or sea lions, and there's many kinds of seals and sea lions and even walruses. And those guys are in a group called Carnivora. Now, in dinosaur world, we have theropod, the predator dinosaurs mainly. Mammals have carnivore. Now, carnivore with a little c means you eat meat. Carnivore with a big C is the actual order, and that includes two branches. The felid branch have cats, mongooses, saber-toothed cats, of course, the big panthera, lions, tigers, hyenas, those kind of things. The canid form have dogs, bears, otters, raccoons, like that. So seals are actually in the canid form. So what you're seeing here are three types of mammals that all went to the ocean in different ways. Just like the mosasaur is one branch. I did a whole video on marine reptiles. There's a mosasaur, which is actually closer to snakes and lizards, Squamata, that order. And then the plesiosaur and pliosaur are a separate branch too. So those are different groups. So, and of course, sea turtles like the archelon, the giant sea turtle, that's a different branch too. So there we have three different branches of reptile going to the ocean separately. Here, three different branches of mammals doing the same thing. So the question now was, well, wait a minute, Basilosaurus, what are you then? What are you related to? Who are your relatives? Well, it turns out historically we thought they were a group called mythinikids, which is its own situation. So the idea here is just follow me, just hear me out. There are these hoofed carnivores. So I mentioned the word ungulate in the last two videos with Colecotherium and the Paraceratherium. Ungulates are hoofed animals in the mammal world, and the two major branches are the Percerodactyls, who are odd-toed, which are 3 or 4 toes that are weight-bearing, so horses, rhinos, tapirs. The other group are Pterodactyls, which are the even-toed, so your sheep, your cows, let's say your giraffes, pigs, hippos. So basically, mythinikids, based on their skull design, had very similar features when compared to early whales like Basilosaurus. The problem is, well, that was cool. They're like, oh, these weird things that aren't here anymore became whales. Case solved. Close the book. We're done. But it turns out we kept digging and we found things like Pachycetus, which there's no toy of. A Pachycetus, if it were standing on my table, would be about that big. So this is an animal that has more features, morphology, shape-wise, aligned with whales. We see animals like Ambliocetus, which essentially is a mammal, but like has a crocodile, like amphibious, living close to the water. So again, I would go. I do lectures on this all the time. But the idea is that we see these other groups leading towards that. But the question then is, if mythinikids are not the ancestors of whales, first of all, interesting enough, this is a Antrusarchus, which is a 2005 safari figure. And Antrusarchus was considered the largest mythinikid for a long time. It had like a 3-foot skull found in Asia. And now they're saying, actually, it's not a mythinikid. There's still a group of mythinikids. But this is actually possibly a relative of Entelodonts, the, quote, killer warthogs, but not really warthogs, found in the Oligocene and so on. So that's a whole another video there. But looking at it, turns out whales are closely related to our pterodactyls. So you would assume, just on like face value, large teeth, and sometimes you're like, oh, like whales are like just water dogs. Like, no, we already have those. They're called seals. The point is, the idea here is that the pterodactyls are their own branch, basically. And whales are an extension of that branch. Now, in my website, my mammal section, I have like our pterodactyl. I could click on it, see all the examples in toy form. I'll put a link below. But in whales fall under that. I still make cetaceans their own little area because I'm just me. It's my website. I can do what I want to. But it's still know that technically whales, cetaceans as a whole, are considered members of our pterodactyl, even to ungulates. They don't have hooves. Yeah, but it turns out it's not about. It's about your evolutionary line too. Like biology, it's that. Not a good example. My thought is very simple. Is like imagine like biology is just this last snapshot. We're looking at the world around us right now. The fossil record is very deep, has really deep roots. So it turns out there are animals that are closely related to each other. So for example, if you look at a manatee and an elephant, they are very different animals. But if you look at manatees, they have very similar toes on their flippers. Well, not toes, but the nail part, like an elephant, right? There's a list of these things in textbooks everywhere. I'm not going to bore you with all the details. But if you were asked, what is the closest relative of cetaceans? It's hippos. So let that sink in for a minute. You're going to sit here, and you're going to think about that. Now, you said, well, they're both in the water. It's not just that. I mean, but the idea is that you're looking at evolutionary lines, the hippos are the closest to whales. And so are the pigs and camels and giraffes, for example, are closer than a whale is to like a dog or a seal. So genetics, of course, change everything. When I was in school, there's like the family, order, class. We still have that too. The phylum, kingdom, phylum, class, order, family, genus, species. We still have that. But now in these trees of life, they're being dictated, I guess the word, by genetics. So that's kind of changing things up. So we're looking at that. If you look at who is the closer to a whale, I'm looking for my parentage. Like, it's gonna be hippos. So with that mysterious overview, and a lot more to come. This is why we have comments. You can comment, like, subscribe. Oh yeah, I have 272 subscribers. I appreciate every one of you. I appreciate every like, because I am just a guy with a lot of prehistoric models who like talking about science, and most of my lectures and things are very specific topics in certain areas, so I can't go over these like really weird detail things. So I appreciate you being here and doing that. Leave a comment, like below. I think this is my 100th prehistoric model video, which is either really, really impressive or really, really sad. But next in January, I bought like, I think 5. They're down there. I bought like 5 or 6 of the new Jurassic World figures. I'm going to tie them to the family tree of life and all that. So I look forward to doing that for you, and I'll see you guys next year. That being said, thank you for tuning in.